Good day everyone. So for today's video, we're going to solve the problem of the pretest of air conditioning. So we answer the question 80 to 90. So the first question is question 80. We have this problem. Which of the following aspects is not true in the context of dry compression in a vapor compression refrigeration cycle? So we have A, increase in refrigerating effect, B, increase in power consumption, C, improvement in coefficient of performance, D, complete evaporation in the vapor. So the answer is letter C. Because while dry compression ensures the compressor's safety by preventing liquid slugging, it typically leads to higher discharge temperature and increased work input, which generally result in a lower COP or coefficient of performance compared to with compression. So the next question is question 81 is in an ideal vapor compression refrigeration cycle, the specific enthalpy of refrigerant in kilojoules per kilogram is. So we have inlet of condenser or H2 is equals to 283, exit of condenser H3 is equals to 116, exit of evaporator H1 is equals to 232. So the solution is to solve the COP, we have the formula of COP equals refrigerating effect over work done, or we have H1 minus H4 over H2 minus H1. So we must plug in the given. So we have 232 minus 116 over 283 minus 232. So we compute it. So natin makuha nga 116 over 51 over 51. So i-calculate na siya, makakuha dahil tag 2.27. So the answer is letter A, 2.27. So the next question is given enthalpy values of exit of vapor is H1 is equals to 350 kilojoules per kilogram. Exit of condenser, we have H3 is equals to 225 kilojoules per kilogram. Exit from compressor H2 is equals to 375 kilojoules per kilogram. Refrigerating efficiency is equals to 0.8. So we must find the power required per kilowatts of cooling. So first is to solve the COP. We have COP is equals to H1 minus H3 over H2 minus H1. So plug in the given. So we have 350 minus 225 over 375 minus 350. So i-calculate na rin siya, makakuha tag 125 minus 125 over 25. So i-divide na to siya, makakuha din tao ang COP na to is 5. So next is pagkuha sa conceptual COP. So we have ideal COP times refrigerating efficiency. So plug in the given. So we have 5 times 0.8, makakuha taog actual COP na to nga 4. Then lastly, we should get the power per kilowatts of cooling. So we have 1 over actual COP. So plug in the given. So we have 1 over 4. So i-divide na to siya, makakuha din tag 0.25. So the answer of 82 is A, 0.25. So the next question is we have question 84. Which of the following components in a vapor absorption plant in a substitute for the compressor of the vapor compression system? So the answer is letter D, absorber, aqua pump, and generator. Because in a vapor absorption system or VAS, the mechanical compressor is replaced by a thermal compressor consisting of an absorber, refrigerant into a solution. a pump to increase pressure, and a generator to boil off the high pressure refrigerant. So the answer is letter D. So we have a question 85. In the ammonia vapor absorption system, which of the statement is or are correct? First is ammonia is the refrigerant and water is the absorbent. 2 is there is transfer of heat from weak ammonia solution to strong ammonia solution. 3 is the circuit comprising the condenser, expansion valve, and evaporation is called the refrigeration circuit. So the answer is letter A, 1, 2, and 3. So the explanation is the statement number 1 is correct. NH3 is the refrigerant and the NH2O is the absorbent. So statement number 2 is correct. A heat exchanger is typically used to preheat the strong solution going to the generator using heat from the hot weak solution coming from the generator. So statement number 3 is correct. The high pressure side to low pressure side transition via condenser valve, expansion valve, and evaporator constitute the core refrigeration cycle. So the correct answer is letter A. So the next question is question 86. So the question is, in a vapor absorption refrigerator, heat is rejected in. The correct answer is letter D, condenser and absorber. Because the option is in the image is standard VES. Heat is rejected to the surrounding in both condenser to liquefy refrigerant and the absorbent, since absorption is an exothermic process. So the correct answer is letter D. So the next question is we have question 87. The question is, which of the following components is common between vapor compression and vapor absorption system? So the answer is letter C, condenser. Because the reason is both systems rely on a condenser to reject heat and convert the refrigerant vapor back into a liquid state. The primary difference lies in how they compress or increase the pressure of the refrigerant. A mechanical compressor versus an absorber or generator assembly. So the answer is letter C. So the next question is we have question 88. So the question is, aqua ammonia solution used in vapor absorption refrigeration system is a solution of ammonia in. The answer is letter A, water. Because aqua refers to a water. In this system, water acts as the absorbent that dissolves the ammonia refrigerant. So the correct answer is letter A, water. So the next question, question 89, we have a question about in aqua ammonia and LBR water absorption refrigeration system, the refrigerant are respectively. The answer is D, ammonia and water. Because the reason is, in an aqua ammonia system, ammonia is the refrigerant and water is the absorbent. In a lithium bromide or Li-Bru system, water is the refrigerant and Li-Bru is the absorbent. So we have the last question, question 90. So the question is, there is need of cooling water if the following units of vapor absorption refrigeration plant. So the answer is letter B, condenser, absorber, and rectifier. The reason is the condenser requires cooling to liquefy the refrigerant. The absorber requires cooling because the absorption of refrigerant in the absorbent is an exothermic process or release heat. The rectifier or hydrator requires cooling to condense any water vapor back in the generator. So only pure ammonia vapor proceeds. So the correct answer is letter B, which is condenser, absorber, and rectifier. That's all. Thank you.